So in the last class we have already discussed what is called proportion. So actually the proportion is the equality of two ratios, and like two ratios, like suppose if we say like A is to B and D is to C, they are two different ratios but they are equal, then we will call it a proportion, and it would look like A by B is equals to D by C. Now there are some other like terms regarding this chapter. Before going to the exercise, we need to know all about them. So first is that what is called continued proportion. Now suppose all the alphabets are in proportion, like they are in continued proportion, like A, B, C, D, E and so on. So now this proportion will look like A by B is equals to B by C is equals to C by D is equals to D by E is equals to E by F is equals to, and so on. So now it would end up on Z, but suppose there are some numbers infinite numbers like A1, A2, A1, A2, A3, A4, like this way. So then this continued proportion will go on and on and on. Anyway, now suppose there are three numbers which are in proportion, like suppose A, B, C, they are in proportion. So now here this A, this one A and this C, this A is called actually the first proportion, the C is called the third proportion, and this B is called the mean proportion. Okay, the B is called the mean proportion as it is in the middle. And there is a relation that we can form very easily from the proportion, that is, if they are in proportion, then A by B is equals to B by C, right, as we have seen here. So like the same manner I have just written this one. So now from here we can write very easily that AC is equals to B square. So this is a very important relation when three terms are in a continued proportion. Okay, so now I'll proceed slowly to the exercise, and today we'll do the exercise 7.2 from the book ML Aggarwal. So first sum that I've selected for this class, here I'm not giving the question number, I'm just giving a question one like this way, because maybe the question number will not match with the new book. Here it is given that if B is the mean proportional between A and C, so B is, I'm just writing only the keywords, B is mean proportion, okay, mean proportion between A and C, okay, it's told. Now we have to show something, so prove that PT A, C, A square plus B square and B square plus C square are proportional, are in proportion actually. So we need to show 1, 2, 3, 4, all these four terms are in proportion. Now in the rough side I want to show you one thing, like A, B, C, D. If suppose these four terms are in proportion, then A by B is equals to C by D, okay. Means if the four terms are in proportion, we write like this, okay, means that A by B is equals to C by D. So I hope all of you have understood. Now as these four terms are in proportion, so it should have like the same way, we should have got something like that, but we need to show it. So we have to show that they are in equal proportion. So what we need to show, if these four terms are in proportion, we need to show that A by C is equals to A square plus B square by B square plus C square. So we need to show this. Let's see how we can show that. Means this is not here, we have to keep it in our mind, so we have to show this. This blue color part is not with us, we have to show this part. So now we will proceed with what we are having. So B is the mean proportional. So as we have understood that if B is the mean proportion, so from the last just from the last part, that is B square is equals to AC. So from here I want to write like this way, like suppose B by A is equals to C by B, because you see if I take this A down, so it would be like here, and this A will be not here, and here it is 2B, because B into B is B square. So if I take one B here, so I think all of you can understand very clearly that this kind of thing we are getting now. So from here, next line, what I would like to do, that it is equals to KSA. Like K is something, we don't know the value of K, but it's a proportional constant, so it is like is equals to K. So now if I equate B by A is equals to K, so we will get like this, and B is equals to AK, and from the second equation, means like C by B is equals to A, so we'll get C by B is equals to A, so we are getting C is equals to BK. Now if you put this value of b here in this equation from here, so if I insert it, so b is c is equals to b into k. So in the place of b I'm writing ak into a, so I'm getting a k square, right? I hope all of you have understood it. So it is actually c is equals to ak square, b is equals to ak, and a is simple as that a. So now we'll try to show this like equality, like whether they're equal or not. They has to be equal because we have to show it. So let's see. So first of all, in the LHS part, if I put it, so in the LHS it was a by c, right? So in the place of c I'm putting this value now what I've got. So a k square, so a cancelled out, so 1 by k square I'm getting, right students? Now I'll put it in the right hand side. So in the right hand side for the proof part, this one we need to prove. So let us write here. So we need to show. So in the right hand side what you can see, a square plus b square by b square plus c square. So in the right hand side then I will get like this, a square plus b square by b square plus c square, I guess. Yeah. So let us put all the values here. Let us put in the place of b square, see b was equals to ak. So in the place of b then I have to put ak its square, right students? And in the place of b square here also ak whole square, and c means, you know, like ak square already and that square. So if I proceed means with the simplification, so here I'm getting a square, here I'm getting a square k square, here I'm getting like a square k square, plus here I'm getting a square k4, right? So let's see what we can take common now. So from the upper part what I can see, I can take a square common, so 1 plus k square will be left. And from the bottom part I can see that I can take a square k square common, so that 1 plus k square will be left. So students, easily all of you can see that a square can be cancelled out, and this 1 plus k square also can be cancelled out. So what we are left with, 1 by k square. So what we have got in same thing like in LHS as well. So let us give question number 1, and you can write more side notes like in this way, like whenever you are putting something like c's value you are putting. So let us give it like something, let us put it here 1, okay, let here we putting like 2, and so here if I give it like 3, question 3. So here after putting here you can put a side note that from 1 actually, right? And here in the side note you have to write beside this step actually, when you are putting the value of b square and c square all. So from 1 and 2. I hope all of you have understood. Now you can write one thing, that this is your equation number 3 and this is your 4. So from LHS RHS, so from 3 and 4 LHS is equals to RHS, hence proved. I hope all of you have understood. The full sum is on board almost, so I hope all of you can see it, and it's a recorded class, so you can check it then and there anytime. Anyway, so proceeding to the next sum from my selected list. So now I'll go to same kinds of proof what I'm having in my next question, question number 2. So in question number 2 they have asked us to do like this. So it's given that if x by a is equals to y by b is equals to z by c, and then we need to show something here. So let's see how we can show that. So we have to prove that a square x square plus b square y square plus c square z square. Okay, so we have to show that by a cube x plus b cube y plus c cube z, its whole square, okay, it's equals to x y z whole divided by a b c. So we need to show that. So I think you can understand now how we will proceed. So we'll proceed like the same manner, like we will take something here, it is equals to k or something like that. So first equation we will build up that x by a equals to k. So from here I will get x equals to ak, right? So this is equation number 1. Then from the second like if I take it with k, so y by b equals to k, so y is equals to bk, right students? Next what I will get, that z by c is equals to k, so z by c is equals to k will give me z is equals to ck, right? Acha, so here it is equation number 3. Now we'll put all these things what we are having now here. So let us put it in the LHS part. So so first of all, if I see properly, here it was a square, sorry, here it was a square x square. So a square will be same. In the place of x square, I'll just put it from 1. So in the place of x, I'm putting ak, so its whole square it would be. Then b square will be remain same, but in the place of y square, I'll put it from here. that is bk whole square. Then again in the place of c square z square I'll put like this, c square will remain same, and the place of z square I'll put the value of ck here, like z ck whole square. Then a whole divided by, it is a cube x, so a cube will be a cube only, and x means ak here, and then b cube y means here bk, then plus c cube z, so c cube will be remain unchanged, and in the place of z I'll put ck. So then whole square was there. Now let's see. So here what we can see now, first of all, sorry, it was not whole square, actually in the proof I've just copied something wrong. It was actually on cube, okay, anyway it was on cube, okay, anyway. So here now we'll just simplify them all, let's see what we are getting here. If we just open up this, it would give us a square k square, so a square k square, and previously one a square was there, so it would be a4 k square, right? And here you see b square k square, so it would be b4 k square, it would be c4 k square. Down one it would be a4k, it would be b4k, it would be c to the power 4k, and its whole cube, right? And what I can see now, that if I take from upper part k square common, so it would be left, we will be left with a4 plus b4 plus c4, and at down if we take k common, then we'll be left with the same thing, a to the power 4 plus b to the power 4 plus c to the power 4, and whole cube was there. Now we can cancel them each other, and here we are getting only k, so we are getting actually k cube. Now one question arises, now in the proof that in the RHS part it was xyz by abc, so how we can show that? We have not got anything abc and xyz. So what I am doing here, I'm multiplying like abc up and down, like here it is k cube, so I am multiplying abc up and down, so k cube by 1 actually, right students? So what I'm doing, I'm multiplying abc numerator and denominator as well. So now in the next line I'll just do a very interesting trick. Here it is k cube, that means there is 3k is there. So what I will do, I'll just distribute in abc, so one is ak, one is bk, 1k with c, and at the bottom abc, right? So now you can see very clearly that in the this equation number 1, 2 and 3, ak means x, bk means y, and ck means z. So I'll just put them, ak means x, bk means y, ck means z. So see, we have got the proof, it's equals to RHS. So yeah, we have got the proof. See, the full sum is on board, so if there is any kinds of doubt if you are facing, please let me know. I don't think so there is any kinds of problem is there. Check individual steps properly and let me know. So I hope it is clear. Now moving to the next sum. So the next sum is on from my list. It's question number 3 according to my question number. It would be here. The question is given something like this, that here they have given 4 things like a, b, c, d. They are in proportion. So let's see what we can do with them. So let us copy the question. If a, b, c and d are in proportion, okay, so then we have to prove something. Actually here in the book there are so many proofs, but I'm just taking few of them, like much interesting how they look, so I'm just taking them out. Anyway, let's see we having 2 proofs, so I'm just choosing any 2 from here. So a plus c by b plus d whole, sorry, it was not whole cube, basically individually cube was given. Anyway, meaning is same, and on the right side it was then a by b, and it was a minus c is whole square, and b into b minus d its square. Okay, now let's try to show this proof. So let's try with the same manner, like if these 4 terms are in the ratio, means in the proportion, so we know that what we can do, like a by b is equals to c by d. Now we'll take it as usual, like it is k, say it's k. So now what we will do, we will just do like the same manner what we have done in the previous sum, that is a by b is equals to k, so a is equals to bk, and from the second equation if we do c by d is equals to k, so c is equals to dk, right? So here let us give it equation number 1, and here it is equation number 2. Now let us go for the proof. Now if I see in LHS part, So LHS. Now in LHS part they have given A plus C and B plus D whole cube is there. Now keeping the right hand part in our mind, we will try to show. So first of all, let us try to put some values here, like A plus C. A is a BK, so I'm just putting BK over there, and C is equals to DK, so I'm just putting DK over there. So and divided by B plus D was given, so it is whole cube was given. So what I can see from the upper part, means numerator part, I want to take K common, so B plus D will be left, and bottom the B plus D was only there, so we can cancel them each other actually, right? So I'm getting now K cube. So we have got K cube now. Now we will do the same manner, same thing in the RHS part as well. So let us give it equation number 3, sorry for that, and we will now proceed with the RHS part. So in the RHS part, what I can see, it is given A into C, A minus C. So A into A minus C, then divided by it was whole square, and then divided by B into B minus D its whole square. So let us see that it also should come K cube only, right? Because we need to show LHS and RHS, they should be equal with each other. So before that we will put all the values like the same manner. So in the place of A I will write BK, here we can see, so BK, and inside also BK, and in the place of C you can write C DK whole square, and in bottom in the place of B again you can write B only, and here also B only, and here in the place of D I'm keeping D only, okay, and it was whole square. Now let's see in simplification part what else we can do. Now here immediately we can cancel this to B, so we are left with K, but from the upper part what I can see, I can take K common from this part, but as it is square, so it would come outside as K square. So what would be left with us? B minus D its whole square, and at bottom B minus D whole square is only there. So if I cancel them each other, we are getting K cube only. And if I give it equation number 4, so very easily you can all see now that here in RHS part we have got K cube, and in the LHS part also we have got K cube. So both of them are actually K cube, so means LHS and RHS, they are equal with each other. So I hope you have understood this sum. This was one proof, and I want to just take another one proof from the same part, or means another part of that same sum. So let us do it here. Okay, so in Roman 2, let's take, means from the same raw materials, I'll just keep this on mind, okay, because it is in the same sum. So this raw material will be useful for us in the second part also, that is equation number 1 and in the equation number 2. Okay, so let's start. Let us take this one. Mostly looks like the previous sum, but it's a bit different. So a square by b square, a square plus b square by c square plus d square is equals to ab plus ad minus bc, then bc plus cd minus AD. Okay, so this is the sum. Now we will just try to show LHS RHS equal. So in the LHS part, if I put now in the place of a square, you can see very clearly that is a was bk, so means a square place I'll write b square k square, then b square will remain same, and in the place of c square I'll write cc equals to dk. So in the place of c square I'll write dk square, d square k square actually, basically, sorry, d square k square, right, and that d square will be same like that. Achha. So now here if you see, we can take b square common from the numerator part. So b square if I take common, so it will be k square plus 1, and if I take like d square common from the denominator part, d square common, so we will be left with k square plus 1. So k square and k square plus 1 we can cancel them, and we are getting something like this b square, sorry, so we are getting something like b square by d square. Okay, so I hope all of you have understood. So from here we have got b square by d square. So now let's see what we have, what we can get from RHS part now. So in the RHS part we have a b. Achha, let us put directly, let us make it shorter. So a was bk, so in a's place I'm putting bk into b was there, plus ad, a means bk again, and d will be d only, minus bc, so b will be b, and c will be dk. Okay, so just let's see once, dk, c was dk, so c equals to dk. Now in the lower part if you see b into c, so b means b and c means dk, plus c d was there, so c means dk and d will be d only because we have not got any value for d, and next part A into D. So A means BK and D means D only. Okay, so means we are keeping everything on the terms with B and D only. We are not making any change. B, D and K. So what I can see from the upper part, I can take one K common, and from the lower part also one K common. Then let's see what I are left with. So we are left with here B into B, B square. Here B into D plus BD. Here minus BD, I guess, yeah. And here if you see, it is coming B into D, yeah, B into D. And here plus D square, and here minus BD, right? Yeah. So BD cancel here, BD cancel here, KK also cancelled out. So finally from the numerator part we are left with B square, and from the denominator part D square. So yeah, it's same like the LHS what we have got that time. So the full sum is almost on board, so all of you can check it very clearly that here also we have got LHS and RHS equal. So just let me just highlight them. Here is LHS and RHS, they are equal, you can see. And in the previous sum also, let me highlight here KQ, here also KQ, so they were equal with each other, right? So I hope it is very clear to all of you. Now if there is any kinds of confusion, please let me know so that I can just rectify your doubts. Okay, so moving to the next sum, it was question number 3 it was. So moving to the next sum, question number 4. So let me take another one, like a different type of sum, so that you can just proceed the whole exercise in your home. So just in this next sum, in my next sum, here it is given that if A, B, C, they are in continued proportion. So if they are in continued proportion, so A by B is equals to B by C, and if I take it is equals to K, so A by B equals to K if I do, as we have done it so many times, so you can now relate it very easily, like A equals to BK, because B will be cross multiplied, and if B by C equals to K if I do, then you will get B equals to CK. Right, students? Now you can put this value of B here also, like A is equals to, in the place of B you are putting CK, so CK into K, so it would be CK squared. So A is equals to CK squared, it's the final thing, and B is equals to CK, and C will be C alone. Anyway, now let's see what is proof, means what we need to show actually. So here they told us to prove that here A plus B plus C into A minus B plus C is equal to A square plus B square plus C square. So we need to show this. Let's see how we can show. So we'll start like the same manner, like in LHS part we'll put everything. So let us copy A plus B plus C, then A minus B plus C. Okay, sorry. So A plus B, A minus B plus C. So let's put now. If I put now in the places of A, CK square, if in the place of B, CK, and C will be C alone. Acha, here also let us put CK square in the place of A, CK in the place of B, and C will be alone. So from the first term from here, what I can see that I can take C common, so it would be K square plus K plus 1, right? And from the second part also I can see I can take C common, so it would be K square minus K plus 1, right? Yeah, it is something like that only. So what we can do now, so what we can do now, it would be C into C, it would be C square. And these terms I want to write like this way, that using a second bracket, so K square plus 1 plus K, then here K square plus 1 minus K, right? I hope all of you have visualized now. One formula has came, A plus B into A minus B, so it would come like this, A square minus B square. So something like this we have got from the LHS part, right? Let us move on to RHS section and let's see what else I can get. So in the RHS part, if I put, you can see the RHS very clearly. It's very simplistic, like A square plus B square plus C square. So let us put, we have all the raw materials here. So A square means here we will put CK square, its whole square, right? Plus B square was there, so B square means CK, its square, plus C square was it. So let us now do. Here if we open the bracket, so it would be C square K4, it would be C square K square, it would be C square. So what I am getting now, it is if I take C square common, so it is coming C to the K to the power 4 plus K square plus 1. So now what I can see, we have already reached to the proof, because see, if I now just let me show you actually. See, I'm writing here k4, I'm writing k square whole square, and 1, I'm writing 1 square. I can write, I don't think so there is any problem. Now I'll just break it into some formulas that we have. A square plus b square, you know the formula, that it is a plus b, its whole square minus 2a into b, right? Now I'll just jump one single step because it has already came. So it is coming k square plus 1's whole square, and it is actually what, you know, students, it is actually minus 2k square, and it is plus k square, so it would give us minus k square, right? So now students, just check out. Just see here what we have got now, means in the LHS part, that it was c square, and inside the bracket k square plus 1 its whole square minus k square. See, same kind of thing we have got here also. So these two, if you tally, you can really understand that we have got and reached to our proof. Means we have proved that whatever we have tried to show. I hope all of you have got it. If there is any kinds of problem, the full sum is on board. Check it properly, pause the video, and if you have any kinds of doubt, please let me know. Okay, moving to the next sum and the last sum for today's class. So it's question number 5. According to my list, it's question number 5. And here also I have wanted to take a like another one type of question. Here it is given, if A, B, C, D are in continued proportion. Okay, they are in continued proportion. So as we have discussed already about continued proportion, we will do like the same way, and we will try to figure out the things. And here to prove here that A plus D bracket B plus C in a bracket minus A plus C in a bracket, another bracket B plus D, it is equals to B minus C its whole square. So we need to prove this. So before proceeding to this means LHS part, we will first make the raw materials ready for our sum. As in continued proportion, we know A by B is equals to B by C is equals to C by D, and we will just take it as it is, as we have already discussed about continued proportion in the beginning of our today's class. So as far as we have done this, like first term by second term is equals to second term by third term. So I want to show you once that in the very fast beginning of the class, today's class, I have shown you. Here you see, don't mix up and don't confuse please. Here another sum, there was in proportion. These 4 terms A, B, C, D, they were in normal proportion. So first term by second term, third term by fourth term is equals to K we have taken. But in when there will be not in normal proportion, they will be in continued proportion. How the things will happen, we have already understood here. Like see, in proportion, normal proportion means 2 different ratios, they are equal with each other, that's why we call them proportion. But like the same manner, if there are so many terms who are in like continued proportion, then we have already understood how we should write them, like A by B is equals to B by C, how we have shown here, like so on and on and on. It would continue like first term by second term by third term by fourth term by fifth term by sixth term, and so on. So don't mix up please between the proportion and continued proportion. Okay, so here in this sum they have given us that is continued proportion, and this sum again I'm showing you, it was in normal proportion. Normal proportion will be written. Okay, so I hope you have understood. So now in this sum, current sum in the question number 5, we have to show that means we have that they are in continued proportion, so we have done like that. So as you will take it as it is K. So now we have done so many sums, so we'll do it directly. So A by B equals to K, that would give us A is equals to BK, right? And from the second equation, like B by C, when I will do B by C equals to K, it would give us B is equals to CK, right? And from the third part, that is C by D equals to K, that means C equals to DK. Then we'll move back, like we'll put the value of C here, like B equals to C means DK. So DK into K is DK square, and if I put the value of this B, that is DK square here in the first equation, so we'll get DK cube. I hope all of you have understood. So now we are having this 1, 2, 3 equations, that's our raw materials. So now we will proceed to our sum. So as here the RHS part is much smaller as far as looking, so we will just proceed with the RHS part here first. Actually usually we will do with the LHS part, but just for I'm just explaining, I'll just show you the RHS part faster. So in the very fast beginning you can see that it is B minus C whole square. So you can see here B and C, so I'm just put the same value, DK square in the place of B and DK in the place of C. So now I can see that we can take DK common. So when you take DK common, it's as it is square, so it would be D square K square outside. And what will be left? it would be left actually dk, as I've taken dk count. So from the first term it would be k left, and from the second term nothing left. That means 1 would be left. So we are left with d square k square into bracket k minus 1 whole square. So let us proceed in the LHS part now. As it is LHS part is a little bit huge, so that's why I'm showing it in later on. So here we have something like this in the yellow part in the LHS. I have just opened up the bracket. So when I've multiplied, I can see that so many several parts have been cancelled out with the same portion. So next on what I've done, I've just proceed with the remaining parts, and in the remaining part when I've got AC plus BD minus AD and then minus BC sorry, so then I've put all the values from equation number 1, 2 and 3. So here after putting it, I've got d square k4 plus d square k square minus d square k cube minus d square k cube. Now onwards I have to just notice on the LHS part, sorry RHS part, what I've got. There is actually d square k square, so I've taken count d square k square. After taking common d square k square, from the first term it was k square left, from the second term it was 1 left, from the third term and the fourth term it was actually k and k left. So minus k it would give you 2k. So here I have jumped a single step. Now by watching this expression you can very easily understand that as it is, let me show you, it's exactly look like this way. And you know that this is the formula of a minus b whole square. So I have written k minus 1 whole square. So which is exactly same what we have got in the LHS, means RHS actually, sorry. So the full sum is on board. You can check it out. If you are facing any kinds of doubt, please let me know. So this was the full class. So the homework for today's class, it would be, here I'm writing what we can discuss in the next class. It would be our exercise 7.2 full. So just complete it, and we will discuss about the doubts in the next class. Thank you.